Hello, my name is Maris. I work for MikroTik, and I will talk a bit about your present that you get in your bags today. So the topics will be, I will talk about a little about this device, wAP, that you got in your bags. Then I will discuss about repeater setups, and the last part will be the Capsman overview and some basic configuration examples. So if you already opened your bag, there was a box in your bag, and there should be this good looking white device. So we also have it in two colors, black and white. Today you received the white one. So its main features is quite powerful CPU, 650 MHz for such a small device, 64 megabytes of RAM, and 16 megabytes of SPI flash. It also has BGN wireless dual chain, Ethernet port, 100 megabits. It has wide input voltage from 11 to 57 volts. You can power it by AFAT switches that support it, passive PoE, and power jack. It consumes only 4 watts and works in temperatures from -40 to +70. It also has the weatherproof casing, so you can put it in under the roof where not a lot of rain is going. So you cannot put it in the pool or something like that, just a small weatherproof device. So how you can attach it to the wall. In the box you have included the bracket and the template for the bracket. You attach the template to the wall, drill the holes, and you don't have to measure anything. Just drill from the template and attach the bracket. It also has the small extension hole where you can get the Ethernet cable so that you don't need to so that you can run your Ethernet cable through the wall. So the same can be done on the ceiling. So by default, its configuration is oriented for home users. Its first Ethernet is protected by firewall. It has the masquerading enabled, DHCP client enabled, and all neighbor discoveries are disabled. So since it has only one Ethernet port, you cannot by default connect to its Ethernet and discover it by Winbox or connect directly to it. So it also has the fast track enabled. Default IP range is as shown in slides. Wireless is also enabled, all chains enabled. SSID is MikroTik, and last 6 characters from MAC address. And also on the wireless interface you have a DHCP server. So to connect to the device you have several options. So you cannot use Ethernet port. So If you have a laptop, then you can connect to wireless SSID and use Winbox WebFig Telnet or SSH. Another method is to use Android phone. And there are two ways. One is a new TikUp, and the other way is the same as for laptops, WebFig. So just use default IP address and default username, admin without password. So if you don't want to use default configuration for home access point, you can press when powering on the board, press the reset button for approximately 10 seconds, and configuration will switch to CAP mode, which means that wireless and Ethernet interfaces are bridged, and DHCP client is enabled on bridge interface. So this will, in this case, you can connect to using Ethernet interface. So here's some screenshots of our Android application, TikUp. You can, if you want to use it right now, you have to apply to our testing program. Link you can find in our MikroTik forum. After registering to testing program, you will be able to download it from Play Store. So in screenshots you can see the default login window, and on the other side you can see the window when resetting configuration. So if you chose to stick with home access point configuration, you just need three things to do. First one is to connect and set your own username and password for security reasons. The second one is disable admin user. It's not a requirement, but for more security you should do it. And the last one is set VPA or VPA2 keys to secure your access point. And basically that's it. You can just forget about this router and leave it, use it for internet connections. So the next part is repeater at home. Let's say you have a large home and one access point, and devices like laptops, mobile phones, what else we have, the toilet seats with wireless and something like that. They don't have a good coverage, so you need at least 2 or more access points in your home. In this case, if you don't want to set up each access point individually and to go around the house and reconnect to each access point, you can set up a wireless repeater. It extends your network and range without any wires. So to make it work, what you need to do is either set up a virtual access point, or you need a device with 2 wireless interfaces. So this router that you received have only one wireless interface. So if you want to use a repeater, then you need to set up the virtual access point. But we have other models which have 2 wireless interfaces. So wireless access point virtual access point is not required. So here's some demonstration. Let's say we have one access point in one corner of the house. We have 2 devices with good coverage, and 2 devices on the other side of the house without the coverage. So to make this work, we just add this device as a repeater. So not a demonstration, but a little talk about how to set it up. So you have two options. First thing you need to do is to set up the physical interface as the station, and for that you have two options. First one is to set up manually to connect to your access point that you already have. In this case, you fill in manually station mode, band, SSID, just like regular client. And station mode should be set to station bridge. That way you can bridge the station on the client side. In this case, it's a requirement. So the other feature is you can use the wireless scan, which is built in router OS. So you just open the wireless window, choose the scanner button like in the screenshots, and the scanner window will open. Choose the wireless interface. In our case, it's VLAN 1. And you can see in the list we have 3 access points discovered. So we choose one that we want to connect from the list and press connect button, and all the data will be filled automatically. So the same can be done from TikUp. You also go to wireless interface menu, choose the scanner tool, choose the wireless interface, and you see on the other side there's a list with discovered access points. So the process is the same. Pick one from the list and press the connect button. So in the screenshot you also see that background scan is enabled. Background scan basically means that when you run this tool, you are not disconnected from the wireless, which is important for devices with only one wireless interface and where Ethernet is protected, so you don't lose the access to the device. So there are some limitations on background scans. It can be run only on 802.11 protocols. Wireless interfaces must be enabled, and it works on both access points and stations. It also is supported on virtual interfaces, and for example, if you want to use it in scripts or for other statistics, you can export this output in CVS file format. So when we set up the station, next part is to set up the repeater access point. In this case, we are using a virtual access point, so we are adding new virtual AP interface. Use the same SSID that you have on your first device, the same security settings if there are any. Add bridge interface with static MAC address. Reason for static MAC address is because if wireless interface disconnects, bridge will change the MAC address. So if we don't want to do it, then the best way is to set up the static MAC address. So then we bridge physical wireless interface with a virtual access point interface. And that's it. So you can also set up the DHCP client or set up static IP address just for management. But it's not required. So after you set up, you can run our built-in tools like bandwidth test to test the speed. It will not show the exact speed that you can get, but it's if it's run from access point directly, because it will consume the CPU and it will not be able to generate the maximum capacity. So also, if you have if you are running station on a router OS and with wireless security settings, then you can also use the VPS client, which router OS is now supporting. So the VPS client is getting the pre-shared keys and all the configuration necessary for connecting to the access point. This received information is showed on screen, and it can be automatically saved to device settings. And the last part is the capsman. This is our controller for access points. So the capsman means Controlled Access Point System Manager. And each device that is connecting to manager is called CAP, Controlled Access Point. So the CAP requires almost no configuration. You just need to lock wireless interfaces to be used by capsman, and you need some kind of connectivity to manager. For example, like IP connectivity or just a MAC connectivity. So, and when CAP connects, there are two packet processing methods. One is centralized and one is local forwarding. So so what's the difference? The local forwarding is when for example, laptop or your phone is connected to CAP. At first, manager with the yellow arrows that you see in the screen sends the configuration to CAP. Now your devices are able to connect to CAPs. And like, for example, the bottom one with the green line shows the local forwarding method. So client sends to CAP the packets, and then packets are forwarded directly to the gateway, and gateway forwards them to the internet. So the manager is just for configuration management. But so there are some pros and cons for this one. So pros for this method is that if you have a lot of CAPs and a lot of configuration methods, then manager doesn't have to be the very fast router. So you can run it on the very simple devices like even the ones that you got in your bag today. And link between manager and gateway is also not so important. So it's just used if the manager needs the internet connection for some reason, or for management purposes, and so on. And the last plus is that clients do not lose connectivity to the internet if the manager fails for some reason, power outage or connectivity between CAP and manager goes out, and so on. The cons is that it's not so friendly for central management. So you need to set up hotspots, firewalls, queues, DHCP servers, and everything on CAP devices. If it's in layer 2 network, then it is possible to run through the manager, but also it has some limitations if it's the large network. So there's another method called central forwarding, which means that in this case yellow arrows represent that manager sends configuration to CAP. now clients are connecting to CAP and sends all the traffic which destination is to internet through the manager. And the manager then forwards those packets to the gateway, and then later gateway forwards to the internet. So in this case, obvious pros is that it's a centralized device. You can run firewalls, queues, hotspots, DHCP servers, anything you want on a single device. So, and also, let's say you want upper cap and lower cap in different groups, in different scenarios. For example, the upper one will be used for the employees in your office, and the lower one should be used for clients without any security settings. So it's very easy to distinguish these configurations in different bridges and run hotspots or firewalls or everything on different bridge for every group. So, but the cons for such configuration is that it's a single point of failure. So if CAP manager fails, CAPs are losing configuration, and also the clients are unable to connect to the internet. So solution for this is to set up the backup managers. So it's just 2 or 3 or more devices. Another con is that it needs a very powerful CPU, since all the traffic is forwarded through the router, and all the management services like hotspots and firewalls are queues, which is very CPU intensive, are running on the same device. So if you have at least like 10 or more caps, I would suggest to use one of our PowerPC devices like RB200 1100 or CCR devices. And the last con is that link between manager and gateway is very important. So for obvious reasons that it forwards all the traffic. So now the configuration part. First I will show how to set up CAPs. So its configuration is very simple. You just open the wireless window, press the CAP button, CAP configuration window will open, and just select enable and choose what interfaces you want to be controlled by the CAPsman. So in this case, I also selected the certificate, which will allow you to secure connection between CAPsman and CAPs. The next one is discovery interface. In this case, it's set up to loopback interface, which means that controlled wireless interfaces are on the same device as CAPsman, which is also possible. And the next interesting settings is CAPsman address. So if you have layer 3 connectivity only, you set up the IP address of the CAPsman, where to connect. And one more important setting is bridge. So if you choose the bridge, wireless interfaces will be automatically added to selected bridge interface. It's required if you are using local forwarding methods. Or in layer 2, in local forwarding methods. So the same, how to do it from terminal, interface wireless cap set enable yes, interface, choose interface which to use, and the other configuration. So as I mentioned in the first part of presentation, you don't have to do it manually. You can simply switch to our default CAP configuration by choosing 10 seconds of reset button. So, and that's it for the CAPs. CAPs manager configuration is a bit more difficult than the CAP. So as I mentioned, the CAPs and CAPsman can be run on the same router. For example, in this room we have HAP-AC routers. One is used as a CAPsman, and second one is just a CAP, but they both are providing wireless for the clients. So to make it work on the same router, when you are configuring CAP settings, just either you specify loopback interface or you specify the loopback address. And the next thing you need to know is for CAPsman to work, it needs several things. The first one is connectivity between CAP and CAPsman to discover its interfaces. Then next part is to have configuration parameters to send to the CAPs. And the last part is provisioning criteria from which CAPsman is choosing what type of configurations it will be sent to the CAP. First thing I will start to show you how to set up the configuration part. So you open the CAPsman window and choose the second tab named configurations. Press the plus button and a new configuration window will open. Here important, in the first tab, important part is choose the mode that it will be access point and choose the SSID. Next one is the channel that you will want to use. In this case is 2 GHz BGN. And the last part is which method you want to use, local forwarding or central forwarding. Central is by default, so in this case I want to use the local forwarding, so I just check in this setting. And finally, security. If you want to use the security settings, just choose which protocols you want to use and the passphrase. If there are any EAP radius or other settings, then specify them in here. And that's it. Press the OK button and you have the new configuration called CFG1. So the next part is the provisioning. So this is very important for controller to know that for which devices to send actually this CFG1. So we just go to provisioning tab, press the plus button, and in my case criteria will be the hardware supported features. In this case I'm looking to set up this configuration for the interfaces that support GN and B standards. The next you need to choose the action. Typically in most cases you simply choose the create dynamic enabled, which means that I will show you later in which menu CAPsman will automatically add the discovered and configured interfaces. And the last important part is the specify master configuration, which we configured previously, in this case CFG1. So in case if you want automatically to add virtual access point also, then there's an option, slave configuration. This slave configuration will be applied to virtual access point dynamically on every cap discovered, which matches this criteria. So, and the last part, we enable the manager by going to first tab, pressing the manager button, and simply enabling the manager. So other options are not important if you don't want to use the security. So if you want security, then specify certificates. If you are generating them manually, or set them to auto, and Capsman will automatically generate all the certificates and also will send them to the all the caps. So you can see also in this screenshot, there's one interface which received the configuration and was dynamically added to the list. Also, you can see all the statistics about remote caps discovered, its IP, serial numbers, versions, identities, and so on. And also there's the radio tab, which is just right after the remote cap tab. It shows the all discovered interfaces, even if they didn't receive the configuration. And the last one is the registration table, just like on regular wireless interfaces, but here you can see all connected clients centrally, so you can manage them by using only one device. So you can see here is the selected rates, wireless signals, and other settings that you would want to use in your, for example, your management program. So, for example, if you have on one device two different interfaces, one is 2 GHz and one is 5 GHz, and you want to provision configuration for both of them. So we just create two configurations and two provisioning criteria, one for AC or A or AN, and the second for BGN. You can also use the common templates. So here in screenshot you can see there are tabs for security configurations, channels, and data path. So when you are configuring, for example, the first screen here, channels, if you don't want to manually specify band for each configuration, you can create the channel template and pick it in the first field. When you enable it, it will show the name configured on the channels tab. So some limitations about Capsman. The first one is that each cap can have only 32 radios. On Rotor's device, this is not a limitation because we don't have devices with such high amount of radios. The second one is you can have only 32 virtual interfaces per each physical interface. But you can have unlimited caps connected to the manager. We also have two versions. One is quite old, version 1, and the second, version 2, which is enabled by default on all current Rotor's versions. So they both are not compatible. So if you had the old Capsman setup, you should upgrade all the caps and the capsman at the same time. It also doesn't support N-Stream and NV2. So, thank you. Also, I can show you the setup that we are having right here now. So you can see in the list, this is the first router, which is the manager, and also its wireless interfaces are controlled by the manager. So you can see that it shows in the red managed by Capsman, and it also shows a bit of configuration received from the manager. So if we open the Capsman menu, here you can see all the clients registered. MUM Mongolia 2 is 2 GHz, and MUM Mongolia 5 is 5 MHz, and here are different interfaces on both caps where clients are connected. So in the radio menu, we have 4 interfaces, 2 for each device. So here you can see 2 caps. One is connected by MAC address, and the second one is used the loopback IP. So in here we have dynamically created interfaces which are also automatically added to our local bridge. So here you can see dynamic ports. And we have only one DHCP server configured on bridge interface. So here you can see we have this one is for camera, it's not important, but this one on bridge interface where all dynamic cap interfaces are added. This one DHCP server is providing IP addresses for all the clients. So the provisioning example that I talked previously, so here we have configuration for 2 GHz. Here selected band 2 GHz. It's called configuration 1. Data path is centralized forwarding, and this setting, here you can see the bridge is selected, which means that interfaces discovered and that applied configuration on the manager will be automatically added to this bridge on the manager device. And the second one is basically the same, just the band is for 5 GHz. So in provisioning, I also have 2 configurations. One is, as you can see, is this for 2 GHz is hardware supported rates GN, and for 5 GHz is hardware supported rates AC. So that is how manager discovers which configuration to choose to each to send to each interface. So that's it. Thank you. Maybe you had any questions? No?